amines, and after that, the D and F block will be continued in that on Friday. It will be completed coming Friday. Okay.
Okay.
So I'm going to uh, start this reaction. We completed up to Gatterman, right? Replacement by
Yes, sir.
halide of nidine. Okay. Now see. The next is replacement by iodide. Replacement by iodide. So how we are going to replace iodide ion with nitrogen? So it's very simple. You have this diazonium chloride, Arn2 plus Cl minus. You are directly going to react this with Ki, potassium iodide. You will be getting your desired product, that is ARI. I just replaced N2 and you will be getting KCl and N2 will be evolved. So this is how we are reaction with N2 with iodide. The next is replacement by fluoride ion. So for replacement by fluoride ion, this is again Ar2 plus Cl minus. So you are going to react it with HBF4. Then you will be getting Ar2 plus BF4 negative. And then you are going to heat it and then you will be getting your desired product. That is ARF, fluorobenzene, BF3. Let me know when you are done.
Yes, sir. Done.
Now, the next is replacement by hydrogen. That means you are going to make it prepare benzene this. Replacement by hydrogen. You see how we are going to replace it with hydrogen and Cl minus. So first you need to react this with Ar2 plus Cl minus. This is your benzene diazonium chloride. So you are going to use H3PO2, which is a reducing agent, mild reducing agent in the presence of water. Then you will be getting, this is your benzene. ARH, that means basically benzene. This is your benzene and this will be converted into H3PO3 and this is your HCl. So if this is reducing agent, it will oxidize itself. You can see it is oxidizes to H3PO3. And either you can use in this diazonium chloride, you can either use alcohol, which will also act as mild reducing agent, and you will be getting ARH. And since it is reducing agent, it will oxidize itself into CS aldehyde, and this is the product that you will get. So, did you make a list of the chapters that you are facing problem?
No, sir. Not yet.
Okay, no problem. So, are your practical over? Is your practical over?
No, it just started, sir. So today we had biotech, and then after that, tomorrow we'll have chemistry practicals, and then 1 day gap, and then physics, and then info, and then after that, I don't know how many gaps, like I think 5 or 4, and then after that, PD.
Okay, okay. Let me know when you are done with this.
Yes, sir. Done.
So this is your replacement by hydrogen. Now we are going to talk about replacement by hydroxyl group. Hydroxyl group. So this is your ARN2 plus Cl minus. You just need to hydrolyze it. That means reacting with water. You will be getting phenol AROH plus N2 plus HCl. This is how you will get replace this OH. And the last one is your replacement by NO2. So it's also very easy. You have this benzene diazonium chloride. Either you can directly write ArN2 plus Cl minus. That's also good. First, you are going to react this with fluoroboric acid. Fluoroboric acid. Then you will be getting this. There will be N2 plus, and here it will be BF4 negative. Then you are going to heat it in the presence of NaNO2 copper and heat it. Then you will be getting nitrobenzene, and the rest part will be by. Please to write. Let me know when you are done with this.
Yes, you're done.
Okay, I'm going to change the slide. Now, the next type of reaction and the last reaction of this chapter, reactions involving, and we need to study one more topic, reactions involving retention of diazo group. Retention of diazo group. The diazo group will be retained in the compound, and this reaction is basically known as coupling reaction. This reaction is known as coupling reaction. And let's see how the diazo group retain in the compound. So this is your N2 plus Cl minus, and you are going to react this with phenol. You are going to react this with phenol. Wait a minute. Now this is your phenol. And you know every carbon will have a hydrogen like this. So you are going to react this in the presence of this, that is OH minus. So what you will get, it's very simple. And 2 will be written in the compound. This is your benzene and double bond N. I'll explain the reaction. First, write with me. And this is what you will get. See this hydrogen and chlorine will be eliminated in the form of HCl, and this double bond, there will be bond between this nitrogen and this carbon, and the double bond triple bond will be broken into this form. It forms this, and it has a name p hydroxy azobenzene. P hydroxy azobenzene, and it is orange dye. The next reaction from this is also similar, and this reaction is known as, this all reaction is known as what we say coupling reaction. You are going to react now with aniline in the presence of base. So see what you will get. See here, it won't be HCl. Basically, it will be Cl minus, and H plus will go with OH in negatives to form H2O. In the same way, there will be Cl minus and H2O. And this compound has a name, the bottom compound, and its name is p-amino azobenzene, para-amino azobenzene, and it is yellow dye. Let me know when you are done with this.
Yes, sir, done.
Done. Very good. Now, the only reaction that I had left in this chapter, before that, I would like to just check this. Okay, we didn't. Can you write the resonating structure of this compound? Please do let me know whether you can write the resonating structure of this compound or no. This is triple bond basically. 1, 2, 3. Can you write this resonating structure of this compound?
I'll try, sir.
Can you write the resonating structure? Yeah, you are trying. Okay.
Um, I don't know if it's correct, sir.
Wait a minute, wait a minute. Yes, so you don't know how to do it, right?
Yes, sir.
Nafisa, see, this N2 plus will act as minus R. That means electron withdrawing group. So it will take electron like this and it will go here. So now you can see the rest part is as it is. There will be positive charge and the rest part will be as it is. Now it becomes double bond and then there will be double bond and negative here and positive here. Now you just need to move one arrow. This will go here. So positive charge will come here. So there will be positive charge. Is my video lagging?
No, no,
Double
sir.
bond, double bond. Then it becomes n positive here, and double bond n negative. Just you need to move only one arrow and you'll get all your answer. And then again,
Yes, sir, I did that. I did till the second one.
very good. Then there will be positive charge and then double bond, then n positive and then double bond n negative. Now you need to move here and then this to there. And then you will be getting your right answer. So in this way, you can do this. Got it?
Yes, sir.
So
Okay.
basically this and this are same, treated as one. So please do write it and let me know. So all the organics are covered, only D and F block left, right?
Yes, sir. We did some in Friday class DNF block.
Yeah, and we will be completing that chapter on coming Friday. So please be available at 6:30 and I will be
Yes,
sending
sir.
the PDF or the PPT.
Okay, sir.
Okay.
Yes, sir. Done.
Done. Very. Now see the part that I had left. Let me just check it. Secondary amines, carbolamine reaction, and okay. In chemical reaction, I started with alkylation. Now we have the chemical reaction in which we are going to see the basic strength, basic character or basic strength of amines. This is most important topic. Okay. So see, if you have a primary amine that is RNH2, and you are going to react this with hydrogen halide. So you know what will happen. This X will be negative, this will be positive, so it will attack here, and it becomes RNH3 positive, and here it will be negative, which is a salt. Now in the same way, aromatic amine like aniline, you can see will react if you have HCl. And then see what will happen. This Cl minus, Cl negative, and now this will become NH3 positive, and there will be force of attraction between NH3 positive and Cl minus, and it has a name, anilinium chloride. Aluminium chloride, which is also a salt, and this is your aniline. So this is about this. Now we are going to talk about the basic strength. So first of all, you are going to write it and let me know. Let me know when you're done with this.
Yes, sir, done.
Very good. Now, can you let me know the extent of hydrogen bonding? Extent of H bonding. If you'll see, if we have primary amines or like this, RNH3 positive, and if we have the secondary amine like this, in which the extent of hydrogen bonding will be more. Can you tell me?
Sir, in the first one.
First one, because it can make hydrogen bonding from here, here,
Yes.
here. It can from two side and in this from one side. So I'm going to
One
write
sec.
it here. Extent of hydrogen bonding in water and order of stability of ions by solvation. So you can think it's more hydrogen bonding. So this. So please do write it. Also, I already told you in previous chapter that basic strength is directly proportional to the group having more plus I, donating group, plus R, directly proportional to Kb, inversely proportional to pKb, and then inversely proportional to withdrawing group, inversely proportional to withdrawing group in resonance, inversely proportional to K, acid dissociation constant, and directly proportional to pK, which is opposite of this. This is how we do. So is there any practical by tomorrow?
Yes, sir. Chemistry.
Chemistry, very nice.
Yes.
You should tell
Yes,
me
sir.
earlier. You should have told me earlier so that I had sent some
Oh,
more.
yes, sir. We're doing the salt analysis titration and organics for the
Mm,
experiments.
okay. So,
Sir,
are
I
you?
told you. You asked me how many practicals I have, and I told you all of them.
Okay. Okay. So, in your syllabus, it is in practical, it is qualitative and quantitative analysis. Is there? Is that in your syllabus?
Volumetric volumetric analysis, is it?
Yeah, volumetric
Yeah.
after that.
Yes, sir. The only the first one. We're not doing the oxalic acid. We're not doing the oxalic one. We're doing the first one, the titration.
Okay, volumetric analysis, right?
Yes, sir.
Do you know what is a standard solution?
This that is that F.
Not a problem. I'm going to send you a volumetric analysis.
Okay, sir.
Okay, it is
Okay.
in the last. So please do write it and then let me know.
Yes, sir.
Just wait a minute. I'm just making a PDF for you. Initially, it is about qualitative and quantitative analysis. Okay,
Yes, sir. Okay.
just let me go. And just wait a minute. And I think on page number what it is 10 around 10. It is your volumetric analysis. So I will recommend you to just read the question. Today you have 35 questions, and I think you can do this, right?
Sir, which one?
I'm sending you on WhatsApp.
Oh, okay, okay. Yes, sir.
Okay, are you done with this?
Yes, sir.
Okay. Now I'm going to give you a question. Arrange the following in decreasing order of basic strength of their basic strength. So you can see this is your C2H5 whole twice NH. This is your C2H5 whole thrice NH. This is your C2H5 NH2, and this is your NH. So you are going, this is your ethylenamine, CH3 whole twice NH, CH3 NH2, then CH3 whole thrice NH. And this is your NH. You are going to arrange A and B. Well, let me know if you're unable to do it. I think you have got it.
So the first one is C2H5, and then yeah, like the
No,
first one
this
is
will be the
the
C. This is your
oh
secondary, this is your tertiary, and this is your primary. So see why it is so.
what?
I
Yes,
told
sir.
you it's very important. As I told you, it's very important. So why it is important? Because if you are going, the expected order will be basically you can see this is your NH and this will be your CH2 CH3. I'm talking about the first one. Okay, CH2 and then CH3. Now, if you're going to talk about this, you will see and and oh, for made a mistake. Wait a minute. Tertiary it is. Secondary it is. In secondary, okay, there is no hydrogen in this. Yeah, it's like this. Okay, so it has here it is CH2 and CH3, and then CH2 CH3, and then CH2 CH3. Then comes your this N, which has two hydrogen, and then C2H5. That means CH2 CH3. And if you are going through this, you can see NH3. So if you're going to basic is directly proportional to plus I, you can see the plus I in this will be from two side, and here in will be from three side and one side. So this should be the most basic, yes or no?
Yes, sir.
But the solvation is the solubility will be lesser here. It is not that much stable due to steric hindrance. So second degree dominant over tertiary, then tertiary comes, and then primary, and after that this NH3. In
Yes,
case
sir.
of
Okay.
R is equal to ethyl group. So secondary, tertiary, primary, and then amine. Now, in case of R is equal to methyl group, secondary again will beat the secondary again will beat the primary and tertiary. So this is 1 degree, this is 3 degree, this is amine. This happens only because of the steric hindrance and the solvation. When it is going to mix with water, it will be more stable. So in when it is alkyl, this is more stable, and that's why it is having at the second position for basic character. So you have to uh, keep it in mind. And there is some questions in NCRT that will be most important question from this chapter. So I will recommend you to do that question, please. Okay, please do write it.
Okay, sir.
Let me know when you are done with this.
Yes, we're done.
Very good. Now the chapter is completed. Do you have any doubts or anything? Yes or no?
No, sir.
Okay, then write this question. It is very important. Arrange the following in increasing order of their basic strength. These questions that you are going to send it to me back.
Okay, sir.
Okay, thank you. Let me know if you are done writing with the question number
Yes, I think
one.
Yes, we're done.
And if you get some time after your practical or before that, please send me the chapters each and every chapters or the topics that you are having problem. This is the only time for you to study hard. So this is for today. Please do solve it and send it back to me. Okay.
Okay, sir. Sir, I'm kind of confused. Like when you write N, like at the back, like for example, C3H, what is that? 9, and then N. Does it mean NH or just N? I'm so
No, no, it is only C3H9 and you can make a formula from here.
yeah, okay.
Like
So that
it will
one,
be
the second question.
CH3, CH, oh, wait a minute, CH3,
Yeah,
CH2, and then CH2, and then it will be, I think, 3 plus 2, 5
yeah,
plus
yeah,
2,
okay.
7,
I
NH2.
understood.
And you are going, yeah. Anything else?
Uh, like for example, the first question, the second part, C2H5 in bracket
NH2,
3, N. Is that
whole twice NH.
no, this the yeah, the
This,
N. Yeah, is
yeah,
that
yeah, it is tertiary. It is only N. Tertiary,
yeah,
that
yeah,
nitrogen makes three bond, right? If
yeah, okay.
nitrogen doesn't have any charge, that makes three bond. So it's tertiary. Is there any other doubt? Just look at the question and let me know.
Yeah, no, sir, that's it. Thank you, sir.
Okay, then thank you. Please do it and okay. And after doing it, you may leave.
Okay, sir. Okay, sir.
Thank you.
Nafisa, are you done with this?
Yes, sir. Just one more question.
Okay.